Alright, hey y'all. We are going to do a video on the features of parabolas. So we determined that a parabola is something that looks like this. It has a U shape, and generally it's modeled by things that are thrown in the air. So if you throw like a football or a toy or something like that, it will have this U shape. If you flipped it upside down, this image here, it's exactly the path that something would take. So we're going to determine some key features of these parabolas and write down some definitions. So the roots and the solution of a parabola is also the point or points where the parabola will cross the x-axis. And this is when y is equal to 0. Another word that you might hear for this is also known as the zeros. So roots, solutions, and zeros are all the same thing. I'm going to label these on the graph here. So each of these points here, in this case there are 2 solutions, is a root. The axis of symmetry is the equation of the vertical line that will split the parabola in half. And it's going to be because it is a vertical line, it is always given as x equals. So whenever I ask you what the equation of the axis of symmetry is, you need to make sure that you give it to me as an equation, first of all, with an equal sign, and that it's x equals. And any vertical line will have an equation that is x equals. All of those dotted lines that I just put on this image here all have coordinates that are the same x value. In this case, they are x equals 1. I'm going to label this on my image. I'm going to go back to the roots too. I wanted to also write what the solutions were in this case. So in the green dots that crosses the x-axis, we have that x will be equal to -1 and 3. Great. So the vertex of a function is the lowest or highest point where the parabola will change direction. In this example, it is the lowest point, and it is all the way down on the bottom here. I will label this as the vertex. And it's always written as an ordered pair. So you have the x value comma y value, and the x coordinate will always be the value of the axis of symmetry. So in this example, the vertex would be 1 comma -4. And then the y-intercept is where the parabola crosses the y-axis. And where the parabola crosses the y-axis, any y-intercept will always have an x value of 0. So if you have an equation for this parabola, you would just plug in 0 for x, and that would be the vertex that you would get, or sorry, the y-intercept. In this case, the y-intercept is 0 comma -3. So now we are going to algebraically determine what the axis of symmetry and the vertex will be given some equations of parabolas. So the axis of symmetry will always be given by this equation of -b over 2a. And those values can be determined by taking a look at the b value of a parabola and also of the a value of the parabola. So you just plug in whatever those coefficients are, and you would get the axis of symmetry. The vertex can be determined by plugging in the axis of symmetry for x in whichever equation you're working for. Now, we also said in the previous page that the axis of symmetry will always be an x equals thing because it's a vertical line. So let's do just a few examples of what this would look like. So for the first one here, we're going to find the axis of symmetry and the vertex for each of these quadratics here. So always start off with the axis of symmetry if you're being asked to find the vertex, because you need that in order to determine the vertex. So I need to determine what my b value is and what a is going to be as well. Let me use a different color. So b is going to be 16 in this case, and a will be whatever coefficient's in front of x squared, and in this case it is 1. So we are going to use that equation, x equals negative b over 2a, and we'll plug in these values. So negative 16 over 2 times 1. So that's negative 16 over 2, and that is negative 8. So the axis of symmetry, I'm going to label this as AOS, is going to be x equals negative 8. So to determine the vertex of the quadratic here, we need to plug in for x. So I'm going to take my negative 8 and plug it in wherever I see an x. So negative 8 squared plus 16 times negative 8 plus 71. And then you're just going to crank this through on your calculator. So we have negative 8 squared is 64, and then plus 16 times negative 8 plus 71 is going to give us an answer of 7. So that was a y value that you determined. So that means that the vertex is negative 8, that was your axis of symmetry, comma, 7. And that's it. So the stuff on the left-hand side was all about the axis of symmetry, and the stuff on the right side was the vertex. So let's do another. Let's take a look at the next one. So I know that the a value here is going to be negative 1. There is a negative 1 that's in front of x squared, and then b is going to be negative 14. So to find the axis of symmetry, actually I'm just going to label these right now, axis of symmetry and then vertex. So to find the axis of symmetry, we need to be using negative b over 2a. So we'll plug in, and that's equal to x. We'll plug in negative 14 over 2 times negative 1. So now we have a few negatives here. Remember that a negative times a negative is a positive, so actually I have 14 over, and then 2 times negative 1 is negative 2. So now I have positive 14 over negative 2. That means your axis of symmetry is going to be negative 7. I'll write that over here. And then the vertex is just found by plugging in whatever x value that was into the equation. So we have negative 7 squared minus 14 times negative 7 minus 59. And then plugging that into our calculator, negative 7 squared is 49, but we also have a negative here, so it's negative 49 minus 14 times negative 7 minus 59. And when plugging that into your calculator, you should get that y would be equal to negative 10. So that means that your vertex would be the point negative 7 comma negative 10. Great. And then I'm going to do one more. I'm going to do 3x squared plus 24x plus 49. So A, in this case, is 3, and B is 24. All right. So to find the axis of symmetry, you do x is equal to negative b over 2a. You get that x is equal to negative 24 over 2 times 3, which will be negative 24 over 6, and therefore x would be equal to negative 4. So that's your axis of symmetry. And then to find the vertex, we just need to plug in negative 4 to our equation. So 3 times negative 4 squared plus 24 times negative 4 plus 49. Ooh, I'm running out of room. That's a 49 over there. So negative 4 squared is 16, and 16 times 3 and then do plus 24 times negative 4 plus 49. And that turns out to be 1. So y is equal to 1 in this case, so that means that our point is negative 4, our axis of symmetry, comma 1. And that is it. So just be careful when you're plugging these into your calculator. Make sure you're using order of operations and lots of parentheses wherever you see exponents especially. So we're going to stop here. We'll see you next time.